We're going to be looking at keyboards. So we concluded on the mouse, and today we're going to device that we have system. Today we're going to look at the keyboards, and then also we're going to discuss the keyboards and then how keyboard works. Okay. So let's do and then layout of the keyboard. So we say that the standard computer, normally computer keyboard has basically 100 keys. Okay, so if you look at a standard keyboard, it has basically 100 keys. Okay, and all the keys are functional and they should be used by a computer system, okay? And by the end user in a computer system. Okay, so now we are saying that most keyboards use what we call the quad layout. The main reason why they use something known as a quad layout is because it's named from the first 6 keys on the top rows of the letters. And how does it look like? It basically looks something like that. All right. So you can see we've got the Q, we've got the W, we've got the E, we've got the R, and then we've got the T, and then we've got basically the Y. So this is the most standard keyboard, and they're basically named as what? Okay? Because of the first 6 letters. The first 6 letters are constant, which is a Q to a Y. They're normally constant. Okay. Layout is the most used keyboard, right, in our machines. Even if you look at your laptop keyboard, you find that from the top there, you find that it has basically 6 letters that are uniform, which is a Q, W, E, R, T, and Y. So basically, when you find them aligned like that, then the layout of the type of keyboard you're using is something referred to as a quad. Then, most keyboards have several, okay, have keys that are arranged in 5 groups. Okay, most keyboards have keys that are arranged in 5 groups, which is number 1, something alphanumeric, okay, keys. So we've got the layout or the group of alphanumeric keys, and then we've got the group of numeric keypads, okay, and then we've got the group of function keys, and then we've got a group of modifier keys, and then lastly, we've got something known as the cursor movement keys. So these are the 5 most groups of keys that are found on the keyboard. Alphanumeric, we're simply defining things like the hash symbol, the question mark, the exclamation mark, the dots. Those are alphanumeric characters, the @ symbol. So you find that there's a layout of all those alphanumeric keys that you need in order to insert data into your computer system. And then the other thing, we've got numeric keypads are those that contain numbers, not 1 all the way to 9. 1 all the way to 9 with a 0, of course. So they're basically decimal numbers. They're basically decimal numbers, 10 decimal numbers from 0 to 9. And then these are also critical. These are also critical in computer systems. We're going to see later on how they're used. These are quite important. See them how they're used. Then we've got what we call cursor movement keys. Now, what are these cursor movement keys? Cursor movement keys, you normally use them. In a case that you don't have a mouse, you can basically use a keyboard to move the cursor on the machine. So we'll see how those things work. So one thing we should just understand is that keyboards are basically arranged in 5 groups, which are as mentioned from the PPT. So let's look at them. So this is a pictorial of a keyboard. This is a pictorial of a keyboard. We have basically this thing, which is function keys. So you can see the line in blue there. Those are examples of functional keys, right? Examples of functional keys. And each particular functional key, if I use my pointer, right? Let me just use my pointer. So what we're seeing is this. These are functional keys. So now each particular functional key from this particular keyboard here is used for something. So it's a special function, like from F1 all the way to F4. So basically, a keyboard has got two functional keys that range from F1 all the way to what? F4. And then from there now, we also have a key that is there that is referred to as the escape key, all right? Escape key that is over there, all right? It's used for something else as well in light blue. And then all those that we have mapped in Lect, all those that we have mapped in Lect as a green key, they are known as the alphanumeric keys. Now the key alphanumeric keys here that we can point out. From the first button here, you can see we have the dash, the dot, the exclamation mark, the @ the hash, the dollar sign, the percentage, okay, the raise symbol, the and symbol, the asterisk symbol. Basically, that is not a star, but the asterisk symbol. Two open brackets, and so on and so forth. There are so many that you can see from these. All right. Now, within those same ones, we have got numeric keys, or we have got alphabetical keys. Okay, like from the what all the way to the M, thereabout. All those are keys that are used for something. So the combination of alphabetical and numeric characters in there, hence known as what? Alphanumeric. What about modifiers? Okay, modifier keys. What do they do? So a modifier key is an example of the shift, the control, the alt, right? The at, right? All these are examples of what? Control. The modifier keys that are used within the keyboard itself, right? And then from there now we have got what we call cursor movement keys, right? In green there, if you see the ones in green, marked in green there. We've got the print screen, we've got the scroll lock, pause, reset, home, page up, delete, end, page down, and then the bottom up, down movement, left, right movement. All these are special keys that are used on the keyboard. Now, this is a very familiar face of the keyboard that we are used to, and it's a standard type of the keyboard known as it. The layout known as a pack layout, right? And then we also have something known as numeric keypads, all right? So numeric keypads which are in decimals, all the way from 0 to 9, the standard decimal numbers, all right? So we use them normally to num lock, caps lock, scroll lock, online, and then now we've got the individual numbers there, the numeric numbers there. Enter, we can delete, we can add, we can subtract, so we can even perform some arithmetic operations. We're using arithmetic symbols over there. All right. Okay, so basically we understand from the layout the five standard keys that are found on the keyboard. Remember, we've got something known as alphanumeric, we've got functional keys, we've got modifiers, we've got cursor movement, and then we've got numeric. These are quite important. Now let's look at something known as the ergonomic of keyboards. Right? What is it? So we're talking about to say long period of keyboard use can cause injuries. Now this is the same thing that we were discussing when we discussed about mouse. We are discussing about it now. Discussing about the mouse, we did identify that actually there are serious injuries if you continue to use a mouse. All right, and you need to be at least at a certain posture when you're trying to use. So these are the same things that we're also looking at the keyboard. So when you continuously just use a keyboard for a long period of time, you may cause some injuries within yourself as an individual. And then now got make click correct keyboard can help you avoid injuries. All right, what do we mean? Okay, so you can also avoid injuries by adopting correct keyboard practices, which you have to understand. Correct keyboard practices. What are those? So let's look at the steps. Okay, ergonomic style of the keyboard. Look at that particular type of keyboard. So this type of a keyboard as well allows your movements, okay, or your movements of your hands to really move, not only to stick on one position, but basically to move around because of the way the keyboard itself is shaped. and how the keys are placed in different places. Hence, at least creating some mobility within your joints of your hand, all right, which is quite better, all right, and it's quite okay for better exercises to avoid injuries and so on and so forth, and clamps within you as you are using this particular device, all right. So let's also try now to concentrate on how a keyboard really works. After we have understood that we need to make sure that we practice, okay, we have better practice on using a keyboard and also place it well. So those things that we looked at under a mouse, basically, they also apply on the keyboard. So how does a keyboard work? Right? How does a keyboard work? When you press a key, what happens? Have you ever wondered what happens when you press a key on a keyboard? So the keyboard controller detects the keystroke, all right? One thing we should know is that every component on a computer system contains something known as a controller, okay? Now a controller is just basically a circuit, right? It's basically a circuit responsible for controlling movement of data coming from input device to the destination where it's supposed to go and back again to where it's supposed to go. So from destination to source, from source to destination, right? So that is what a controller is. So a controller is just basically a circuitry that controls movement of data from source to destination of the data system. Keep that in mind. So what that simply means is that each particular component in a computer system, which is what do we mean when we say component? We're basically referring to input-output devices. So each particular I/O, right? Particular I/O device in a computer system contains something referred to as controller. And these controllers are quite critical because this is that all these controllers themselves, they're in different types, right? Make sure that each particular device transmits correct data from source to destination. Now, an example of this input device that we're talking about is this keyboard. So we're referring to say that when you press on a key, the keyboard controller, okay, the circuitry in charge of controlling movement of data from source to destination of this particular device detects that particular key that you are what? Pressed. So a keystroke. And then what that particular controller does, it basically, the controller places a scan code in the keyboard buffer, right? So a keyboard buffer is basically a register. Right? It's a small cell that keeps all instructions coming from the keyboard. So it's a small cell or a small memory responsible for keeping all instructions coming from the keyboard. All right, and it's referred to as a keyboard. So indicating which key was pressed. Now, the reason why the key buffer has to keep what key has been pressed is to avoid miscommunication of which key has been pressed on a keyboard from those 5 keys that we looked at, the alphanumeric, and so on and so forth. All right. So this register, its purpose is to keep that particular key that has been pressed, okay, and then it's stored basically into this. And then the next thing is that then the keyboard sends that particular key as an instruction. All right. Remember, each particular key has got a scan code. All right. A scan code, more like an address. All right. And then that particular scan code is then sent to the computer. All right. An interrupt, which is a request, is sent. All right. So an interrupt is basically a request telling the CPU to say, can you accept this particular keystroke that has been clicked on the key? Now, I want to explain this in the simplest possible terms that you may understand. I'll draw something here. I'll draw the CPU, the box of the CPU. So I say CPU me, I'm not using a touch screen, so basically I'm using my mouse to basically do these things. And then something known as RAM here, right? Remember, we talked about execution cycle of the microprocessor when we started our course. So this should be very easy to understand. I'm just drawing it for a second, ask people to even further understand. So this K I've drawn here is a keyboard. Okay, it's an illustration of the keyboard. And then I'm drawing another line coming down here, two lines. Pointer, right? So concentrate. This is a pointer coming from this straight line. Now, this entire line, all the way from down here, touching this particular part here. So I'll say, okay, we have also something referred to as HDD, which is the hard disk drive. We have something referred to as USB here, all right? And so on and so forth, all right? So all these are different components. These are different components here. When you say IO, they're input and output devices. Okay, so this is USB. So then all these devices here, right? As I've mentioned, all these IO devices at the bottom here, they're basically transmitting data, right, to the microprocessor for processing. They are all connected together, as we are seeing, through this line. This line is referred to as a bus, right? So this is a bus. And this type of bus that connects all the devices together is referred to as the processor. Okay, so I'll name this as processor, right? So processor memory bus. Okay, so that's the name of this particular bus. It's referred to as a processor memory bus. Okay. Actually, well, instead of saying processor memory bus, we then label it as a memory I/O bus. Okay, so this is referred to as a memory I/O bus. There we can using a pen, a touch screen. So that's the name of this particular bus. The main reason why it's referred to as a memory I/O bus, it's because this particular bus connects these I/O devices to send data into this memory. Right? And then remember, we mentioned that the microprocessor, the way it operates, it has to basically fetch everything that it has to work with from a memory, which is known as RAM, right? So it gets everything that it's supposed to work on, and that has been worked on. It's sent to something known as RAM. So a bus is basically just a set of wires. Okay, a bus is a set of wires that connects components together. Now, I'll draw another line on each particular component. So I'll draw this line here, which doesn't look straight. These lines are what now we're going to be calling as controllers. Okay, so we can call these as controllers. Okay. Controller, which is short for CONTR. Okay, so this is a USB controller, that is a hard drive controller, and that is a keyboard controller. So we also have a mouse controller as well. Okay, so we have a mouse there. Before it's connected to a bus, there's a controller in between. So each particular component contains controllers, all right? And these controllers, what they do, they control the movement of data from this device to where it's supposed to go into the RAM, okay? And any data that is going to come now from the RAM to the device itself, all right? So they're all controlled by controllers. Now, the line that I drew earlier, the top line here, which is this particular line here on top, coming from the down here, coming from the down there, and then pointing all the way to the CPU. These are what we refer to as interrupts. Okay, so the basically interrupts being called, and this is the very thing I was mentioning on this point here. Right? I need to shed more light on this point. So the keyboard sends the computer an interrupt request. Now, an interrupt request is going to come from this particular keyboard. An interrupt is basically a confusion or a disturbance caused on the CPU. So what this diagram is simply depicting, it's telling us to say that all interrupts in a computer system caused on the CPU, they are caused by I/O devices. That is a conclusion. So concluding to say all interrupts caused on the CPU, they are caused by I/O devices. So we're basically saying the mouse, the keyboard, hard drive, USB port, basically anything that is I/O device can cause interrupts to the CPU. See? So it simply means you're telling the system, you stop whatever you are doing and concentrate on saving me. You get the point? So if you go to the doctor direct, you barge into the doctor's office and then tell him, doctor, I need you to attend to me. Right? So this is what has happened now to the keyboard. So whenever you press on a key, that particular response for you to see a key appear on your screen, what has happened to the CPU, that is what you refer to as an interrupt request. So you're telling the CPU to accept any keystroke. It doesn't matter what the CPU is doing. Can you stop that and then concentrate on working on my instruction? That is what we're doing here. Now, this diagram I've drawn is normally referred to as a typical I/O system. We together. Referred to as a typical I/O system. Let me pause this. This is how. Then that's good.
Yes.
Right. So this is how simple a keyboard works. Okay, so everything that comes from input devices, which is a keyboard and mouse, they're basically interrupts on a CPU. And they have to be accepted by the CPU. And they have to be worked on by the CPU. And the CPU then has to give us results, display them on the screen to say, this is what you requested me to do. I clicked on the letter A, and what you said is that, can you please display for me letter A on the screen through my keyboard? By virtue of the letter A appearing on the screen, it simply means the CPU has now processed that particular instruction and it has given you the results. Okay. So this is what does translate into code. So key number one here, we are saying basically a key is pressed on the keyboard, and then the keyboard controller, what does it do? Number two here. We're saying now the keyboard controller sends the scan code for the keyboard to the keyboard buffer, which is a register, right? Now the register, this one, the keyboard buffer, what it does is that it keeps this particular keystroke that has been hit on the keyboard, right? And then we said in the keyboard buffer, number three here, we're saying the keyboard controller sends an interrupt request to the system software. Now, where is this particular interrupt coming from? Where is it coming from, and where is it going to get this instruction from? So the CPU is now going to get this instruction directly from the keyboard buffer, right? Then we're saying point number four is that the system software responds to the interrupt by reading the scan code from the keyboard buffer. So it reads from here, right? Now by reading that, simply number five, the system software passes scan code to the CPU. So basically the CPU now works on that particular code. When it works on it, for it to be displayed back, it sends it back to the keyboard buffer, right? From the keyboard buffer to the main memory, and then now to the output device, in this case, the monitor. Right? See something appearing from the system. Great. So very simple and straightforward concept. How it works. How we have explained it. So this is our keyboard. Okay. Do we have